Welcome class, this is the demonstration for the Rube Goldberg machine assignment. It'll cover the key parts of the activity that you need to make sure that you complete, as well as giving you some hints and tricks should you watch through the entire video. On the screen in front of you, in this video, you should see I have one of my screens up. I currently have opened the ball project that is available through the specification document. I know it's set up correctly because I have a ball approximately 1/2 meter radius located 10 meters off the ground and 16 meters away just below the ground, so almost 2 meters below the ground, 16 meters to the right is the cup that we're going to land in. For this project, your goal is to get this ball into this cup in the most obscure and inconsistent way that you can imagine. You're unaware of what Rube Goldberg machines are, please take this time, pause the video, and go and Google and watch a few of these operate on YouTube. Welcome back. So now that you've seen how Rube Goldberg operates, or if you just went through that quick pause, either way, you are prepared to begin building your first Rube Goldberg. This assignment, you need to build a Rube Goldberg machine that includes a minimum of 2 logic statements. Logic statements are basically things that we can introduce that control the situation. So for example, a common logic statement when driving a car might be, if the light is red, you stop. If the light is green, you go. If the light is yellow, you calculate if you could speed through it fast enough. Oh wait, sorry. You begin to slow down in preparation for the red light. That basic, if this, then that. If this is happening, then I will do that. That is one of the most common logic statements we're going to run into, called the if-then statement. The big continuation of that is, if it's this, then I'll do that. What if it's not that? Well, in the real world, there's not yes or no. There's it's this or it's something else. So we add in the else statement. So we have if, then, else. So what you're looking at is what am I trying to meet? If I've met it, I will do that particular item that I said I would do. Or else I will do this other item. So let's look at this as applied to a motor. So I'm going to drag a motor out. I'm going to set a motor up here on the background. I'm going to go ahead and hit escape to get off of that so I'm not laying up more motors. Now I'm going to double click on my motor. Now because I'm working on multiple screens, my control document pops up over here on the side. So let's say I wanted to set this motor up so that it span 100 degrees per second for the first 5 seconds. So if it has not been 5 seconds, I want to spin at 100 degrees per second. I can set that up with an if-then statement. So I'm simply going to type in if So I've typed in if, I followed it by a parentheses. Now I need my condition. Time is less than 5. Notice that I have not, so I have a comma. Notice that I have not utilized units here. My units are out here on the side. So I know that I'm talking about seconds if I'm talking about time. So if time is less than 5, comma, what do I want it to do? Well, I want it to rotate at 100 degrees, so I would do 100 degrees. Once again, no unit, because my unit is located right here. Well, Ms. Higdon, what do you want to do if it's after 5 seconds? So what happens at 5 seconds and on? Do you want to hold still? Do you want to spin the other way? Let's say we're going to have it spin much slower in the opposite direction, so negative 10 degrees. I have set up a basic if-then-else statement. So my if-then-else statement is simply stating if time is less than 5 seconds. So for the duration, the first 5 seconds this operates, you will spin at 100 degrees per second. Else, after that first 5 seconds, you will spin at -10 degrees per second. And then I'm done. That's all it is to set up an if-then statement on here. So I'm going to go ahead and close this out. Now I've set up my motor. So let's bring in a small block. I'm going to set the block, set it here. I'm going to put a green pin in so that I can rotate around this pin. I'm going to drop this motor on top of this pin so that it spins the block around the pin. Oops, helps when you land on top of the pin. So now it's on top of the pin. I'm going to zoom out a little bit so we can see this. So when I hit run, it's going to spin in 100 seconds or 100 degrees for the first 5 seconds. This says, hey, this is broken. So this is good for you to recognize. When you run into this, it's basically stating something has happened, which is meant that my parts are probably shifting through each other. This ball is probably going through that block somewhat. Or it means that we have things that are colliding that can't get past each other. So in this scenario, there's nothing for this blue bar to collide with. It is this ball is going through the block. I need to turn up my accuracy. Now for the second, I'm going to ignore it and say yes. So notice that it throws that ball and then it changes directions. So I'm going to stop it. I'm not going to reset it this time. I want to bring your attention down here. So currently my accuracy is set so that for every second I'll run 100 frames of calculations. So watch what happens here at 490. Notice everything's spinning to the right. Well, once it hits that 500, notice that it will now begin spinning counterclockwise and much slower. So I have to click a lot more times. So right up to 5 seconds, it's spinning clockwise, positive direction for us. After that, it's spinning anti-clockwise, counterclockwise, the negative direction. So I'm going to reset this. I'm going to go ahead and run it again. And I'm going to stop it. Let's say I want to put a backboard here. I want to bounce my ball. I flung it. I want to bounce my ball off a backboard now, right? Okay, I can do that. That's doable. So I want to put a block in right there. Now, Mr. Higdon told you, oh, yeah, you can do that, but you're going to have 2 if statements. And you're like, well, I want this to be my other if statement. I'm going to shoot a basketball goal. That's how I'm going to do this. I'm going to put a block in right there. Well, currently, if I hit run, notice that that backboard doesn't stick. Okay, Mr. Higdon, you have to put an anchor on it. Okay, I put an anchor on it. Now when it runs, sure enough, it sticks. It bounces, and I miss. So I might want to do something to where I interact with this ball. And I could sit here and I could keep adjusting this. But there are other things I could do. So for example, I could figure out mathematically what position I need to put this backboard in to make sure that it goes straight in. So I can find this position through trial and error here. And look, there's where it needs to go in the cut. Now I can apply what's called a body logic statement to this particular ball backboard. So I'm going to double click on it. And notice that its X and Y position are defined. What I can do is I can say, oh, at what time point does it need to be in that X and Y position? So if I look, it looks like that somewhere in the ballpark of 2 seconds, it needs to be up near that position. So how could I tie that number into 2? So we reset it, go back and look at these specific stats. At 2 seconds, I need to be at 22. So I could set this equal and say that this is equal to t times 11. This is also a logical statement because I'm taking one variable and tying that one variable into what that is doing. So a variable is controlling it. This counts as a body logic statement. I can utilize it. Note that for these to work, you have to have an anchor here on this block. Just have to have it. So I'm going to close it out. Notice that my ball is now there. This could be an issue, right? Because as you can see, I have to make sure that it doesn't interfere with this, or I'm going to have to turn off my collisions, which is what I'm going to do here. I don't want these to collide. So I'll select both, do not collide. Now they can overlap and I don't have to worry about it. To make it look prettier, I'm going to go Objects in the back so you can see the ball. Also want to make sure that these two blocks do not collide since they are now going to be moving through the same space. So I'm going to select both of them, Object, do not collide. But notice that my ball and this, I want to be able to collide. And my ball and this, I want to be able to collide or it can't bounce off and land down in them. Now when I hit run, I have the same problem with my accuracy. Oh, and it's moving too fast. So I would have to go in now and say, hey, t times 11 doesn't work. Clearly I messed up. Maybe it was supposed to be by 8. And I can go in and I can fiddle with this. You'll be allowed to adjust these to get them to where they work just fine. And see that a moving block bounces different than that hard stop block. Run it again. Oops, 6 isn't enough. And you can keep playing with it until you find the number that works for you. So you're close. Now I can build something here. That's the basic of body logic statements. So you have basic if-then logic statements and body logic statements. These are probably the two best ways to interact inside of working model with logic. There are some others. If you go digging around online or come up with some ideas, I can talk with you, meet you in a Zoom meeting, and we can go over your ideas together. I have about a week and a half to work on this project, so it's not as bad time-wise as some of the others that we dealt with where you had a very limited amount of time in the classroom space. One final note, when turning this assignment in, I'm going to request that you mark what has logic on it somehow. So just like before, all of your objects need to be named. So for example, I can't call this rectangle, that would lose me points. I need to make sure that it has a proper name. So under your appearance tab, make sure, once again, I'm on multiple screens, so I gotta go grab it, bring it over here for you. Make sure that you set your color to red for any object that has a body logic statement on it. This allows me to find those objects very quickly, double click on them and go, oh, there's his logic, yay. If you have an object that has logic on some sort of one of these green pieces, one of these constraints, then instead of turning the object red, I'm going to ask for you to turn the object orange. So use red to identify objects that have body statements. Use orange to identify objects that have constraints that have these logic statements on them. So you have to have at least 2 objects that are of this red or orange color. You do not have to have 2 reds. You do not have to have 2 oranges. I don't care how you mix them. But you have to have at least 2 things that are colored as such. Avoid coloring other things these colors for this assignment. Feel free to totally deck it out, make it look fancy and pretty. That's your thing. It's okay. Give me something simple. I don't care. We'll note that there are extra points for ingenuity. So how you put together your thoughts on this and make sure those logic statements predict that and show your thought process, that's worth points as much as complexity. Cautions. This program does not like curves. So if you're going to use this curve polygon tool, and then you're going to do something like, oh, this polygon's going to invert on itself. This object is going to cause problems. So no inversions of objects. Other thing, lots of curves tend to actually really slow down these calculations. So I'd be aware of using them, but you are allowed to. You could use them to your heart's content, if that's what you need. Final note about this object. What I will be checking to grade it is, do you have logic statements? Does your ball go into the cup? And when I check your logic statements, do they impact? So if I were to change this, say, to 12, would it still work? Oh, look, it still doesn't work. That logic statement matters in this scenario. So that's some of the ways I'm going to check it. Ball has to go in the cup. You have to have 2 logic statements. The logic statements need to impact how it works. Simple enough? So for example, ultimately, this logic statement right now would not meet muster on this motor, because I could change this time length here to 2 seconds. Would it still operate? And so if I were to change this back to 7.5, I forgot to do that. I change my time duration down here. I run it. It still functions exactly the same. This had no impact on the system. It would not be worth any points currently. So make sure that whatever you do, it impacts the system somehow. Final note. When you run into errors like what I've been clicking through each time, sometimes you need to fix it by turning up your accuracy. You do not want to exceed an accuracy of 2,000, just a recommendation. Even past 800, it's pretty difficult. Second thing, anytime you make that change down here and you run it, note that everything is slowed down compared to real life. So now that is 1 second past because it's 800 frames per second. That is coming up on 2 seconds past. We're coming up 22, 23, 24, 3 seconds past. And note that it is a different result than what we had before we adjusted accuracy. So be aware of adjusting your accuracy. Make sure you do it earlier rather than later. You're running into errors. But note, by fixing my accuracy, I am no longer having that glitch I was having before where it kept asking me, hey, there's a constraint problem here. What do you want me to do? If you have any questions, don't be afraid to get a hold of me. I can open up a Zoom meeting with you and start working on your working model. Have a great day.